Good evening, dear students. Can you hear me?
Yes, ma'am.
Okay, fine. Okay. So today we are going to start with the new topic, that is aldehyde, ketones, and carboxylic acid. Okay. So what are aldehydes, what are ketones, and what are carboxylic acid? Yes, what are these? So in our ACE classes, we have studied in detail about what are aldehydes, what are the physical, chemical properties, right? What are the preparations of aldehydes, right? Similarly for ketones and carboxylic acid, right? So we have seen the different reaction methods of preparation, right? So these all things we have discussed in the chapter aldehyde, ketones, and carboxylic acid. So coming to your aldehydes, okay, how do you represent aldehydes? How do you represent aldehydes? It is represented by R, C, double bond O, H. Right. So aldehydes are represented how? R, C, double bond O, H. Right. So your R, right, R can be a alkyl or a aryl group, right? But here one of the carbon is attached to one bond of the carbon is attached to R group, aryl or alkyl group, and one of the bond of carbon is attached to a hydrogen. So this is your aldehyde. Ketone means what? How you represent ketone? So carbonyl carbon, okay, and you have R C double bond O R dash. So your R and R dash will be what? It can be a alkyl or a aryl group, right? So so this way we represent our aldehydes. Sorry, ketones. Okay. So RCHO is your aldehyde and RC double bond O R dash. Okay, it is your ketone. So and carboxylic acid. What is carboxylic acid? RC double bond O OH. Right. So these are the functional groups. So these are also a class of organic compounds. So aldehyde, ketones, carboxylic acid. So these are all organic compounds which consist of carbon, oxygen, hydrogen. Right. And here okay, so these are the functional group. Okay, that is the carbonyl. So which what group is present here? Carbonyl group is present, right? There is a presence of carbonyl group in this compound: aldehydes, ketones, and carboxylic acid, right? So carbonyl group. So these are all termed under carbonyl compounds. Okay, so these are all termed under what? Carbonyl compounds. So let us start with the questions. Okay, so this is our first question. The compound on dehydrogenation gives a ketone. So what is the original compound? So what is dehydrohalogenation? So many times I have discussed what is dehydrohalogenation. Dehydro, not halogenation, it is dehydrogenation. Okay, it is dehydrogenation. So the compound. So which is the original compound? A, tertiary alcohol, B, carboxylic acid, C, primary alcohol, and D, secondary alcohol. So which among the following, so which is the compound when it undergoes a dehydrogenation? Dehydrogenation means what? Removal of hydrogen. Okay, hydrogen molecule. So removal of hydrogen molecule will result into a ketone. Okay, will result into what? Will result into a ketone. So so there are four options. Okay, there are four options. A tertiary alcohol, is it a carboxylic acid, primary alcohol, or a secondary alcohol? Yes. Okay. Baby has answered it as D. Anil Kumar Rathod and Amulya have answered it as C. Okay. Here, when we say primary alcohol, so primary alcohol, when it undergoes dehydrogenation, it will form uh, aldehyde. Okay, it will form aldehyde. So first option is wrong. But when you have that is your primary alcohol is a wrong. Okay. Then when we see a secondary, if we consider a secondary alcohol, so if we consider a secondary alcohol, so this is our secondary alcohol. So this secondary alcohol, okay. So if it undergoes hydrogenation, means removal of hydrogen. Okay, so how it removes, you have to use a dehydrogenating agent. So I can use copper. So copper is a dehydrogenating agent. Okay, at 300 degrees Celsius. So what it will do, it will remove the hydrogen. So if I remove this two hydrogen, what you will get? I am going to get a ketone. What I am going to get? I am going to get a ketone with the removal of hydrogen. Okay, so secondary alcohol. So option number D is the correct answer. Option number D is the correct answer. Yes, Lubna and again Amulya has also answered. Yes, it is D. Okay. Yes, baby has also answered it as D. So D is the correct answer. So when you consider a secondary alcohol, okay, it will undergo dehydrogenation. That is why removing the hydrogen molecule, you will get a ketone. The resulting product will be a ketone. So to obtain ketone, what should be a starting product? It should be a secondary alcohol. It should be a secondary alcohol. Okay, let us go for the next one. Which of the following organic compounds answers to both iodoform test and Felling's test? Which of the following organic compounds answers to both iodoform test and Felling's test? A. Ethanol, B. Propanol, C. Ethanol, and D. Methanol. So which of the following organic compound answers both your iodoform test and Felling's test? What is Felling's test? What is Felling's test? Felling test is used for detection of what? For aldehydes. Right. Now, if you take Felling's test, for Felling solution, you will take what? Copper hydroxide. Okay, copper hydroxide. So, Felling solution plus a base like NaOH. So, NaOH and copper hydroxide. So, what it should give? So, if it is a positive test, it will give you a red PPT. Okay, it will give you a red PPT. Then, so it should be what? Felling's test is answered by what? It is answered by aldehydes. Okay, it is answered by aldehyde. Then second is what? Your iodoform. Next is what? Your iodoform. Okay. So next is your iodoform. So iodoform test. What is seen in iodoform test? Yes. So here what you are going to do? So this also a test. Okay, it is given by. So if you have a aldehyde, okay, so it will react with iodine. Okay, iodine in the presence of base like NaOH, and it gives you a yellow PPT. It gives you a yellow PPT. Now here, if I consider ethanol, okay, if I consider ethanol, so ethanol is what? CH3CHO. So ethanol, when it reacts with your copper hydroxide, okay, in the presence of a base like NaOH, you are going to get what? You are going to get a cuprous oxide. Okay, that is a red PPT. So this will show the positive test for Felling solution. Okay, and you will get a sodium acetate plus water. So these are the byproducts obtained. Okay, then iodoform test again. So if I take acetaldehyde, okay, if I take acetaldehyde and if I react it with iodine in the presence of NaOH, okay, what I'm going to get? I am going to get a sodium formate. Okay, I'm going to get a sodium formate, and yellow color is due to what? Yellow color is due to your CHI3. This is a iodoform. Okay, this is the iodoform. So iodoform, because of iodoform, you get the LOPPT, and sodium formate, then water plus sodium iodide. Okay, so these are the byproducts. So option number A is the answer. So acetaldehyde, or it is called as what? It is called as the ethanol. Okay, so yes, baby has answered, Yuva has answered, Amulya has answered, Lubna has answered. Yes, very good. Okay, so many have answered it as A, and yes, A is the correct answer. So, among this, propanol is what? Propanol is what? Propanol is a ketone. So, ketone won't answer this test. Then, ethanol is what? It is a alcohol. So, alcohol also won't answer this test. Then, methanol. Methanol is also wrong. Okay, so it is A. A is the correct answer. Okay, let us go for the next one. Waxes are esters of. Waxes are esters of. Okay. Waxes are esters of A. Glycerol and fatty acid. B. Long chain alcohols and long chain fatty acid. C. Glycerol. D. Long chain alcohol. So, what are these waxes? So, waxes are esters of. So they are what? Waxes are the esters of long chain of saturated and unsaturated fatty acids. Okay. So waxes, they are made up of what? They are made up of long chains of saturated and unsaturated fatty acid. Okay. And along with that, there are monohydric alcohols. Okay. Monohydroxy alcohols are also present. So yes, B is the correct answer. So waxes are esters of long chain of alcohols and fatty acid. Yes. So next question. So there is a reaction. Okay, you have a reaction, that is acetic acid. So acetic acid is there. So that you are treating it with what? You are treating it with acetic acid. Okay, I am treating it with lithium aluminum hydride. After treating with lithium aluminum hydride, I am going to get X. I am going to get what? X. This X, further I am going to treat it with what? I am going to treat it with copper. Okay, copper at 300 degrees Celsius. Copper at 300 degrees Celsius. Then what I am going to get? I am going to get Y. I am going to get Y. This Y, further I am going to treat it with dilute NaOH. Okay, and I'm going to get Z. I'm going to get what? Z. So in the above reaction, what is Z they have asked? A. Aldol, B. Ketol, C. Acetol, and D. Butanol. So acetic acid, we are reacting with lithium aluminum hydride to give you X. This X further reacts with copper in the presence of 300 degrees Celsius, give you Y. This Y further is treated with dilute NaOH to give you Z. So you have to find what is Z in the following. What is Z in the following? Yes, find out. Find out what is Z in the following. Okay, let us see stepwise. Okay, let us see stepwise. So let me write here the reaction. Okay, so let me write. So acetic acid, CHCCOOH. Okay, acetic acid, I'm going to treat it with lithium aluminum hydride. What is the role of lithium aluminum hydride, student? Lithium aluminum hydride is a what? It is a strong reducing agent. What it is? It is a strong reducing agent, right? So the role of lithium aluminum hydride is what? It is a strong reducing agent, right? So after treating the acetic acid with your lithium aluminum hydrate, what you are going to get? What will, after reduction, what will happen? What do you mean by reduction? Removal of hydrogen, right? It is your reduction. So after treating your acetic acid with this, so that will be lithium aluminum hydride. So what we are doing? Lithium aluminum hydride is a reducing agent. So what is the role of reducing agent? Reducing agent of what is reduction? Addition of hydrogen. Okay, addition of hydrogen and removal of oxygen So in the presence of your lithium aluminum hydride, so these two oxygens are removed and two hydrogens are added. So what I'm going to get? I'm going to get CH3, okay, then CH2 and OH. So what I got? I got a ethanol. What is this? It is a ethanol, right? It is alcohol, ethanol. Now this ethanol, further, I'm going to treat it with copper at 300 degrees Celsius. Just now we saw what is the role of copper. What is the role of copper? Copper is also a dehydrogenating agent, right? It will remove hydrogen. Copper. Okay. In the previous question only, we have seen when you treat with the copper, what is the role of copper? It is used as a dehydrogenating agent, right? We remove hydrogen. So again, further we are going to remove this hydrogen. Okay, so what I'm going to do, so it will be CH3. What it will be? CH3CHO, right? So this is our Y. This is what? This is a acetaldehyde. Okay, so from acetic carboxylic acid. Okay, from carboxylic acid, I got alcohol. From alcohol, I got what? I got a aldehyde. Okay, from alcohol, I got a aldehyde. Now, this aldehyde, further, I'm going to treat it with what? Dilute NaOH. What is role of dilute NaOH? It is a strong. It is a base. So, what I'm going to get now? So I'm going to get CH3, C double bond O, H, right? So this is acetaldehyde. So when I treat this with your what? So this here only. Okay, so this I have written here. So just I have to show you how you write this acetaldehyde. So I'm going to treat it with what? Dilute NaOH. Okay, dilute NaOH. So after treating it with dilute NaOH, what will happen? So here there will be formation of CH3, C H O H, okay, and your CH2CHO. So this is the product obtained. So what will happen? Your acetaldehyde, okay, your acetaldehyde will undergo aldol condensation. It will undergo aldol condensation. So because when there is a when you have a this what aldehyde and in the presence of base, we have seen, right? It is what? It is nothing but your aldol condensation. It is what? It is a aldol condensation, right? So like this. So two aldehydes, okay, they undergo aldol condensation. So in aldol, okay, your uh, this aldehyde and OH hydroxy group, they are formed. So this is your aldol condensation. So what is the answer? It is A. It is what? It is A. Yes. Amulya has answered. Preeti has answered. Lubna has answered. Okay, very good. So A is the correct answer. So what are the steps? So first we have taken acetic acid. Acetic acid, we are reacting it with a strong reducing agent like lithium aluminum hydride. So what is happening? There is a removal of hydrogen, sorry, addition of hydrogen, okay, and removal of oxygen, and it results into a alcohol, okay, which is X. This alcohol, further, I am treating it with copper at 300 degrees Celsius. So copper, we have just seen that it is used to remove hydrogen. So from this alcohol, again, a molecule of hydrogen is removed. You get a acetaldehyde. This acetaldehyde, it will undergo self condensation, okay, with the aldol. Sorry, with the aldehyde, one more aldehyde in the presence of dilute NaOH. And what I'm going to get? I'm going to get a aldol form. I'm going to get a aldol, right? So it is A. Answer number, option number A is the answer. Okay, so please study aldol condensation, very important for theory also. Next question. The compound which is not formed during the dry distillation of a mixture of calcium formate and calcium acetate is A. Propanol, B. Propanone, C. Ethanol, and D. Methanol. So, dry distillation. So, which are the compound which is not formed during the dry distillation of mixture of calcium formate and calcium acetate? Okay. Now, if I take a calcium formate, so calcium formate is what? Ca. This is formate. Okay, formic acid is what? COOH. So this is your formic acid. Okay, now one of the hydrogen. Okay, one of the hydrogen is replaced by what? It is replaced by your calcium. Okay, now calcium is plus 2. Right, so this also should be 2. So it is formic. So this is calcium formate. So calcium formate, when it undergoes dry distillation, it will give you what? One product will be your methanol. Okay, another product will be your calcium carbonate. Okay, one will be your methanol, and another will be your what? Calcium carbonate. Okay, then next is again calcium acetate. So again acetic acid, one of the hydrogen is replaced by calcium. Okay, one of the hydrogen is replaced by calcium. So this is plus 2, this is okay, so this should be 2. So this is calcium acetate. So calcium acetate, okay, when it undergoes dry distillation, what I'm going to get? CH3, C double bond O, CH3, okay, plus calcium carbonate. Okay, so when the mixture of calcium formate and calcium acetate, when they are subjected to dry distillation, okay, when they are subjected to dry distillation, so following products are formed. So methanol is formed, and this is a propanol, and this is what? Propanol is formed. Okay, now what we'll do? So together, so if I do this, what? So when this two mixture, so individually they will give you methanol and propanol. Now, when the mixture of this, okay, when the mixture of this is formed, so what it is going to form? So CH3, COO twice, and Ca. When you heat this mixture, okay, what you are going to get? You are going to get a 2 CH3, and this is CHO plus calcium carbonate. So I'm going to get what? I'm going to get ethanol. Okay, I'm going to get ethanol. So only what is formed here? Only ethanol is, propanol is formed, right? So only what is from here? Propanol is formed. So here CH3, C double bond O, H. So this is what? This is your propanol. So option number A. Okay, option number A is the answer. So yes, Amulya, Yuva, Lubna have answered. Yes. Okay. So option number A is the correct answer. So when which is not formed during the dye distillation of mixture. So here you can see, right? So this is what all is formed. Your ethanol is formed. Your what is formed? Methanol is formed, and your propanol is also formed. So which is not formed is propanol, right? You have seen. So separate distillation when we do of calcium formate, what I got methanol. When I do a distillation of calcium acetate, I got propanol. When I did the mixture of both, okay, when I did the mixture of both, that is your formate, calcium formate and calcium acetate, what I got a ethanol. I got what? I got a ethanol. Okay. But and what is not formed? They have asked, right? So it is propanol. So propanol is not formed. So option number A. So rest all products are formed. Option number A is not formed. Okay. Next question. And organic compound X is oxidized by using acidified potassium dichromate. The product obtained reacts with phenyl hydrazine but does not answer silver mirror test. The possible structure of X is, so an organic compound is there, X, It is oxidized by using acidified potassium dichromate. Okay, so how we are going to solve this particular question? So let us see. Okay, so organic compound X is there. This X reacts with what? It will react with the phenyl hydrazine. Okay, it will react with phenyl. X is oxidized by using, okay, it is oxidized by using, so X will undergo oxidation using K2Cr2O7. Okay, it is a good oxidizing agent. And I am going to get what? Okay, I'm going to get Y. Okay, I'm going to get Y. Now this Y further, it will react with what? It will react with phenylhydrazine. Okay, it will react with phenylhydrazine. Okay, then this phenylhydrazine, whatever the product XYZ is there, it will not answer the silver mirror test. Okay, it will not answer the silver mirror test. Silver mirror test is answered by whom? Silver mirror test is answered only by aldehydes, right? Ketone does not give this test. So this is a aldehyde. So the Z is should be a aldehyde. So they have asked what is the possible structure of X. They have asked what is the possible structure of X. Now, if so, there should be a product which on oxidation, okay, the starting reactant X should be what? On oxidation, we should give you Y. This Y, when it reacts with phenylaldehyde, should give you Z. And this should be a aldehyde. This should be what? Aldehyde. Why? It should be aldehyde because because it does not answer the silver mirror test. Okay. So ketones. So ketone will not answer. So aldehyde will answer the test. So this whatever the Z is there, that is not answered. So it is not aldehyde. So leaving then aldehyde, okay, because it is not answered. So leaving then aldehyde means it should be a ketone. Okay, it should be a ketone. Fine. Now let us see. So what are the options? So this is a ketone. So we have to find what is X. Okay, what is X? So first is your ketone. Second is what? CH3 twice CHOH. So this is a alcohol. Then aldehyde, again one alcohol. Right. Now what is the possibility? Okay, what is the possibility? Now when we take a so this is what? CH3 C CH3. Okay, so we know that whenever we have a secondary alcohol, okay, we know that whenever we have a secondary alcohol, what we get? We get a ketone, right? We get a ketone. So it is a possibility of primary alcohol is least. Why? Because primary alcohol, if we take, then after oxidation, you will get what? You will get a this what? You will get a aldehyde. Okay, so now we have to take a secondary alcohol. So if I take a secondary alcohol, this particular secondary alcohol, further I did what? Oxidation. So what should be the Y? What should be your Y? So your Y should be CH3 C double bond O and CH3. So this is our propanol. So what is our Y? Y is our propanol. Now this propanol, further it is reacting with phenylhydrazine, that is C6H5 NH NH2. So this is our phenylhydrazine. So after forming when it reacts with phenylhydrazine, it is not reacting, it is not giving you silver mirror test. Okay, silver mirror is not formed. So after reacting with phenylhydrazine, what is the product form? It should be CH3C. Okay, CH3. So the reaction occurs at this carbonyl carbon. So what will happen? So double bond NHC6H5. So phenylhydrazone is formed. What is formed? Phenylhydrazone is formed. Okay, now here whatever the oxidation product of X is there, okay, so when it reacts with phenylhydrazine, okay, so it is having what? It is having a carbonyl compound. So this carbonyl compound which is of ketone, it will not answer. Why? Because it is a ketone. So we know that ketones does not answer the silver mirror test. Okay, because aldehydes only answer the silver mirror test. So ketone, whenever you want ketone, so your starting product should be what? It should be a secondary alcohol, because secondary alcohol only, when you do oxidation, when you have secondary alcohol, and when you do oxidation on secondary alcohol, only those will give you ketone. So our X should be ketone. So sorry, our X should be what? It should be a secondary alcohol. So option number B. So option number B. Yes. Lubna has answered. Okay. Okay. So option number B is the correct answer. So organic compound X. Okay. So which it is? It is a secondary alcohol, because primary alcohol, if we take it, when you do oxidation, it will form aldehyde. But when you take a secondary alcohol, when you do oxidation, it will form a ketone. Okay. Next question. Next reaction. The reaction involved in the oil of wintergreen test is, the reaction involved in the reaction involved in the oil of water green test is, so salicylic aldehyde, salicylic acid. Okay, you are going to heat it. You are going to heat it in the presence of concentrated H2SO4. In the presence of concentrated H2SO4 to give you a product. So this further, the product is further treated with sodium carbonate solution. Okay. So what is the missing reagent in the above reaction? So they have asked which is the missing reagent. A, NaOH, B, ethanol, C, methanol, and D, phenol. So salicylic acid, let me write the structure of salicylic acid. Salicylic acid is what? OH and your C double bond O. Right. It is what? So this is a salicylic acid. So this is our salicylic acid. So this salicylic acid, okay. So the when you do esterification, okay. So of methanol, uh, so how esters are formed? How esters are formed? So when alcohols, okay, when your alcohol and carboxylic acid react, they give you ester. Okay. So here, which is our alcohol to be taken? Now here the when you take a when you take salicylic acid, okay, and in the presence of your compound. So if I take methanol, that is CH3OH. Okay, if I take a methanol, that is our alcohol methanol, in the presence of concentrated H2SO4, okay, and heat, what I'm going to get? I'm going to get a ester. I'm going to get what? I'm going to get a ester. So what is the ester? It is C double bond O CH3 plus byproduct is water. So this, okay, this is called, it is a methyl salicylate. Okay, it is a methyl salicylate. This is called as what? This is called as oil of green, winter green. Okay, this is called as oil of winter green. Okay, so option number C. So salicylic acid, when it reacts with methanol, okay, it forms the oil of winter green. So methyl salicylate. The product name is what? Methyl salicylate. Okay, the product name is what? It is a methyl salicylate. So salicylic acid, when it reacts with alcohol like methanol, okay, what you are going to get? I'm going to get what? I'm going to get the methyl salicylate. Okay. Next question. The compound which forms acetaldehyde when heated with dilute NaOH is. The compound which forms acetaldehyde when heated with dilute NaOH is. So what is acetaldehyde? CH3C double bond OH. So you when you heat it with NaOH, dilute NaOH, okay, which is the compound which gives you acetaldehyde. Okay. So the options are 1,1,1 trichloroethane, B 1-chloroethane, C 1,2-dichloroethane, D 1,1-dichloroethane. Okay. Now, how are aldehydes obtained? This is what? This is a aldehyde. How is this aldehyde obtained? Aldehydes are obtained by hydrolysis. Okay, hydrolysis. So by doing hydrolysis, what is obtained? Your By doing hydrolysis, what is obtained? Yes, aldehydes are obtained. Right. Now, if you do hydrolysis of what are geminal dihalides? So, what do you mean by geminal dihalide? Geminal means what? On the same carbon. Okay, on the same carbon, what is present? Your This is present. Okay, halogens are present on the same carbon. Two halogens are present. Now, if you take a geminal dihalides, okay, if I take a compound like geminal dihalides, okay, so they will undergo what? Hydrolysis. Okay, after undergoing hydrolysis, aldehydes are formed. So, so if I take the 1,1, so 1,1 means what? On the same carbon. So 1,1 dichloroethane. So 1,1 dichloro, okay, and ethane. 1,1 dichloroethane. So this is 1,1 dichloroethane. So if I treat it with NaOH, if I treat it with NaOH, it will give you what? The Okay, let me write it properly. So this is 1,1 dichloroethane. So when you treat it with NaOH, okay, what I'm going to get? I'm going to get CH3, C, H. So your Cl atoms are replaced by OH. So I'm going to get OH and OH. Okay. Now this is unstable. This is unstable. Okay. So what will happen? There will be loss of water molecule. Okay. There will be loss of water molecule and you are going to get aldehyde. And you are going to get what? Aldehyde. So this is about your how formation of acetaldehyde. Okay. Understood up to here? All the questions are clear. Any doubts up to here? Yes. Any doubts? Okay. One more question. The compound obtained when acetaldehyde reacts with dilute aqueous NaOH exhibits A. Geometrical isomerism, B. Optical isomerism, C. Neither optical nor geometrical isomerism, D. Both optical and geometrical isomerism. So, we have studied about the isomerism, so I won't repeat about the isomerism again. Okay, so which is the compound obtained when acetaldehyde reacts with dilute aqueous sodium hydroxide? So what is the resulted uh, isomerism? So acetaldehyde, let me write CH3, C double bond OH. Okay, when it reacts with NaOH, okay, dilute NaOH. Okay, so what I'm going to get? So it will undergo what? It will undergo self condensation. It will undergo self condensation. How it will undergo condensation? That is aldol condensation. It will undergo what? It will undergo aldol condensation. Right. So there will be formation of aldol condensation. And what I'm going to get? I'm going to get CH3, COH. Okay. Then H. Then CH2 and C double bond OH. So this is aldol. Now, whatever now in this product, now you have to find the geometrical isomerism. Okay. Now, how many stereogenic center is there? Now there is a it has a stereogenic center. Okay, one carbon. This carbon has a stereogenic center. So one, two, three, and four. Right. So it will show what? It will show a optical isomerism. So B will show what? It will show a optical isomerism. Yes, Preeti has answered it correct. L- Lubna has answered it correct. Yes, B is the answer. Okay. So the remaining questions, okay, we will see it in the next class. Any doubts up to here? Any doubts up to here? Any questions you have? Any doubts? Okay. Others? Okay then. So I'll end the session here. Okay. So we'll meet in the next week. Thank you.